Imagine you are standing on the shore, feeling the ocean's roar. The waves crash against the rocks, sending spray high into the air. You feel the energy, the power, the rhythm of the sea. But have you ever wondered what makes these waves tick? What drives their motion, their shape, their fury? Welcome to the fascinating world of waves. Waves are all around us, from the light that we see to the sound we hear to the earthquake that shakes the ground. Hello friends, वेलकम बैक टू स्ट्रिक्टली लॉजिकल, जहां हम साइंस के कॉम्प्लिकेटेड कॉन्सेप्ट्स को बनाते हैं सुपर सिंपल। जब हम वेव्स के बारे में सोचते हैं हमारे दिमाग में सबसे पहले ओशन वेव्स का ही सीन आता है, क्यों, है ना? लेकिन वेव्स सिर्फ समुद्र में ही नहीं होती हैं, बल्कि लाइट, साउंड, रेडियो सिग्नल्स और इवन गिटार की एक वाइब्रेटिंग स्ट्रिंग भी वेव्स का पार्ट होती हैं। तो चलिए वेव्स के इंपॉर्टेंट टर्म्स को समझते हैं, जैसे एम्पलीट्यूड, वेवलेंथ, फ्रीक्वेंसी, और ऐसे कुछ हम फैक्टर्स भी देखेंगे जो कि इन्हें अफेक्ट करते हैं। सो लेट्स स्टार्ट। वेव्स एक डिस्टर्बेंस है जो किसी मीडियम के थ्रू ट्रैवल करती है, जैसे एयर, वाटर और स्पेस, एंड इट ट्रांसपोर्ट्स एनर्जी फ्रॉम वन प्लेस टू अनदर। देयर आर डिफरेंट टाइप्स ऑफ वेव्स दैट ट्रांसपोर्ट एनर्जी थ्रू डिफरेंट एनवायरमेंट्स. Sound, earthquakes and waves in water are all mechanical waves, means they use a medium, means actual physical particles move to pass the energy along. The birth of a mechanical wave starts with a disturbance. The still water of a lake, skipping stones into a pond can be great examples for observing how a disturbance can start a wave. Other examples could be wind, a jet ski, ships, fish swimming in the pond, volcano erupts, etc. all make waves. Energy added to the water by all these things spreads outward in all directions. So actually, energy is applied to the medium and the particles bump, push or pull against one another. These vibrations transfer the energy from one place to another, while medium it's transferred through stays put. All the particles move back and forth or up and down or around in circles. They don't actually change their location. It's only the energy that travels. So, when you hear that sound from afar, you can think all the little particles that transfer that wave from here to there. तो चलिए अब बात करते हैं मैकेनिकल वेव्स के बारे में। जैसे कि मैंने आपको बताया था कि मैकेनिकल वेव्स कैरी एनर्जी थ्रू अ मीडियम फ्रॉम वन प्लेस टू अनदर, बट डिपेंडिंग ऑन द मीडियम द एनर्जी इंटरैक्ट्स विद द पार्टिकल्स इन डिफरेंट वेव्स. Waves that move the medium up and down are called transverse waves, and the waves that move the medium back and forth are called as longitudinal waves. A transverse wave causes the particles to move in a direction perpendicular to the direction of the wave. Imagine waving a long rope up and down to produce curvy S-shaped pattern, while a longitudinal wave causes the particles to move in the same direction as the wave, creating areas of compression or rarefaction in the direction of travel. Each of these waves have characteristics that can be measured to determine the distance between the waves, or you can say how fast the medium vibrates and how intense the energy is. First, you have the wavelength, which is the measurement of the distance between one peak, or you can say from one compression to another. Then there is frequency, which is a measurement of how many waves go by in a period of time. Time and frequency are inversely proportional to each other. Then amplitude measures how intense the wave is, how far each particle is getting pushed from its original resting position. The higher the amplitude, the more energy the waves are carrying. So whether it's a loud noise or a big ripple versus a little one, these waves all share certain measurable characteristics.